Hello everyone, and welcome to day 2 of the beginning of integrals. Today is integration by substitution. It's the opposite of chain rule. We also call it U-sub for short. So we have the steps right here. You're going to choose an appropriate U. It's usually the inside of whatever it is, so inside the parentheses, with the quote complicated part, the something part that I call it in class. Now you're going to find the du, so take the derivative. This is the derivative right there. Express all parts of the integrand in terms of u, take the integral, and then plug back in. So let's just get started by actually doing a problem here. So let's get that pen set up. So again, the inside right here is what we are going to let u be. So we're going to say u equals x squared plus 1. Now the nice thing is that when I take the derivative here, du over dx. Now we don't need the dx here, but that's what I'm taking the integral with respect to, so I'll write it 2x. And then notice here I jumped a step. Is that I have to find du. I have a du over dx because I take the derivative with respect to x. So what I'm going to do is multiply by dx to both sides. So I can write that du equals 2x dx. Now, know that I don't need to show that every time. What you can go right to is this step here. So this is the reason why the dx's cancel out and you have a 2x dx on the side. But to make life easier for all of us, we're just going to be able to say du equals 2x dx and write the dx at the end. Now the nice thing here is notice that we have 2x dx, we have 2x and a dx here. So what I'm going to be able to do is rewrite the integral. Using this information, I can now rewrite it as u to the 50th du, because I know that du takes care of this 2x dx. Well, the nice thing here is I can now take the integral of that. We just did it last class, u to the 51 over 51 plus c. And now I'm going to plug back in to get it in terms of x, because we can't leave it as u. So u is x squared plus 1, so I'm going to get x squared plus 1 to the 51st all over 51 plus c. And that's what the integral is. Using this information, we know the integral of 2x, parentheses, x squared plus 1 to the 50th, dx is x squared plus 1 to the 51st, all over 51 plus c. And when you guys get an original point, you can always find c. So, moving on. Cosecant x plus 9, cotangent x plus 9. Well, clearly the insides are x plus 9, so we're going to say u equals x plus 9. And then du equals 1 dx. So when we look here, there's our dx, our x plus 9s right there. And so we can rewrite this integral using the information that we have as the integral of cosecant u, cotan u, du. And we know what the integral of cosecant u, cotan u, which is negative cosecant u, which we then plug back in terms to get negative cosecant of x plus 9 plus c. I'm done. That's our answer. So it's really doing the same thing over and over and over again. Let's go to the next page. So what I had just shown you guys in the first page were some easier problems. Let's get into some more difficult ones. Here u is going to equal 5x. Du is going to equal 5 dx. Now notice that we do not have a 5 dx here. We only have a dx that we need to substitute in for, or to get rid of, to get in terms of u. I do not have a 5, so what we can do is divide by 5 and say that du over 5 equals dx. Now another way to write this is 1/5 du, correct? So when I go to rewrite this in terms of u, we can write 1/5 out in front. Okay? The integral of sine u du. Now, The dx equaled 1/5 du. I brought the 1/5 out in front and then substituted the dx with the du. So now I can say that equals 1/5 negative, parentheses, negative cosine u. Well, I can plug right back in 5x plus c. I'm going to get negative 1/5 cosine 5x plus c. Done. The key here is to know that you divide by 5 to bring that 1/5 out in front. So this next one, notice that we have something divided by something to the 5th. So I'm going to say u equals 1/3 x plus 8 du then equals 1/3 dx. Notice that we have a 1 dx here, and we need just the 1 dx, so I'm going to multiply by 3. So 3 du equals 1 dx. So this 3, again, is just a constant. Don't worry about it. We'll bring it out in front. So this is going to equal 3 integral of du over u to the 5th. Now another way to see this is just writing that as 3 integral of u to the negative 5 du. Well, we know how to take the integral of negative 5, u to the negative 5. So we can say this is equaling to 3 of u to the negative 4. Notice that we're adding 1 over negative 4 plus c. And so we can rewrite this as negative 3 over 4. Notice that you have u is to the negative 4. We know that u then is going to come into the denominator. And so we're going to say u, which is 1/3 x plus 8 to the negative 4. Well, they brought it down, so now it's positive 4 plus c. And there's ways to rewrite. You could have brought the negative 3 out, negative 3 over 4 out in front, and then wrote it as 1 over 1/3 x plus 8 to the 4th. But either way, it works. The key here, knowing that you can bring up u to the 5th into the numerator to make it u to the negative 5, and you can take the integral of u to the negative 5. This next one, you should be able to clearly see what u is. U's the inside. So we're going to say u equals 3 minus 5t to the 5th. And then du equals negative 25t to the 4th dt. But notice here, the only thing that we need to get rid of is this t to the 4th dt, not have the negative 25. So we can also say that du over negative 25 equals t to the 4th dt. Now I have exactly what t to the 4th and dt is, and we can go to work. So I can say this equals negative 1 over 25, that's the constant here, brought the negative 25 out, integral of the cubed root, so u to the 1/3 du. So I've taken care of the t to the 4th dt, and so that's a u. In u to the 1/3, I can take the integral, it's just the power rule, so just draw that arrow down. Then I can say negative 1 over 25, add 1, u to the 4/3 divided by 4/3 plus c. Show you that. This, another way of saying divided by 4/3, again, this is all algebra. And I know that we struggle with algebra, but we need to be able to see this, that when you divide by 4/3, we multiply by the reciprocal, so I'm going to get negative 3 over 100. 4 times 25 is 100. Parentheses, 3 minus, well, let's think about this. This is the cubed root of 3 minus 5t to the 5th raised to the 4th power plus c. Again, there's another way to write that. You could have put this all on top, all divided by 100. That doesn't matter. As long as it's written in correct notation, you're good to go. This one, I just put this one in here to make you guys understand that we have two separate terms. We have this term and we have that term. So you guys can separate that by saying 1 over x dx plus the integral of secant squared of pi x dx. You can separate it. Well, we know what the integral of 1 over x is. That's going to be ln of x, and we're going to do the absolute value of x. Plus, What's the u here? Well, I'm going to do the u out. Let's do the u just up here. Of course, I picked red. Let's try this one, just so we don't mess it up with that one. U will be pi x. Du will be pi dx. And notice that we only want a dx out in front, so we'll say this is 1 over pi. So the integral 1 over pi comes out in front of secant squared u du. And we can then say this is the ln of the absolute value of x plus the integral of secant squared, tangent. You know the derivative of tangent is secant squared, so we're going to say this is the integral of secant squared is tangent. So 1 over pi tangent of u, pi over pi x, plus c. Done. And the last one, because we can rewrite this as something squared cosine x, we know that u we will want to be sine x, which means du will be cosine x dx. Why is that nice? Look at that, cosine x dx right there. So we can rewrite this as the integral of u squared du. And look at that, it's just u cubed over 3 plus c, which we then know is sine cubed x plus c. Knowing here that the u was sine x and we didn't have to divide by anything, which is nice. Except for the fact it would have been nice. I need to make sure that this is being divided by 3. It's the 1/3. Forgot that. Easy thing to forget, so don't. The last one here that we've got, what do you think u is going to be? Well, u is going to be the exponent. So we'll say u equals the square root of x, which is x to the 1/2. And du, we then know is 1 over 2 square roots of x. Look at that. We could break this up into 1 over square root of x multiplied by e to the square root of x over 1 dx. And look at what I have here, 1 over square root of x, 1 over square root of x. You need to get rid of that 2. So we've got to be able to see we can split that up. So get rid of the 2 by doing 2 du, 1 over square root of x. And now I've taken, dx, can't forget that. Now I've taken care of, if you can't see that, let me try to help you. 1 over square root of x dx, 1 over square root of x dx. And so therefore, I can now rewrite this as 2 integral of e to the u du. The 1 over square root of x dx became 2, that's a 2 du, and I'm just left with e to the u. Well, I know that what the integral of e to the u is just e to the u. So e to the square u, which is square root of x, plus c. Done. I realize I skipped a step there, so I can rewrite that as 2 e to the u plus c, and then I can plug in u, if you didn't see that. So there it is. That is the beginning of U-substitution. We will be doing another day on U-substitution. It does get a little more difficult, but for now this is the, quote, more simple way of doing it, or simple problem. So good luck, and I'll see you in class.